Okay. Have you joined any one of the parts? Three 47. Durgarao. Screen sharing కనిపిస్తుందమ్మా? Anybody? 306, 333, 347. Anybody respond?
కనిపిస్తుంది సార్.
Okay. Thank you. So we are starting the new subject in this third year, second semester, metrology. Okay, as per syllabus, we have the limits, fits and tolerances as first unit. Second unit is related to the linear and angular measurements. And third unit is connected to the measurement of surface finish by different techniques. Okay, because surface finish is a very important part, because if there is a poor surface finish, there is wear and tear between the parts, and we have to replace the components in a shorter period of time. That's why we have to maintain the surface finish. That we'll see in the ensuing chapters introduction. And fourth and fifth units are the gears, measurement of gears and measurement of screw threads. As far as gears are concerned, we are in the syllabus, we have only the spur gear metrology, only spur gear, not bevel gear or other gears, helical gear. We have only spur gear. So we have the screw thread metrology, types of screw threads. Some it is drawn in machine drawing, but here the measurement part will see the parameters which are necessary to ensure the quality of the screw thread. And last unit is the hello. Last unit is nothing but we have to go for the alignment tests, different machine tools, but we have in the syllabus only lathe machine, alignment acceptance test on lathe machine, milling machine, and radial drilling machine. So as far as the complete course is concerned, so what is the student? So we have to discuss the course outcomes in the beginning itself as a protocol, or we can say, because the students should know the syllabus or what is the outcome after you learn from the different units or different chapters from the faculty for the concerned subject teacher. So first we have the course outcome 1. So whenever you can know this after you complete, but we'll try to specify the course outcomes for this subject. So we have to design the parts, the components we draw in machine drawing or production drawing. So we have the lot of disturbance. I don't know because of any particular student or A section or B section. So as far as the chapters are concerned, we have divided units. If there is online class, some of the units will be delivered by me and some by Chandrarao Garu. Going for section B. Hello, don't talk among yourselves. You are thinking that you are safe, but when you come to offline class, you'll be in trouble. So I think mute is not working. I don't know if you are unmuting yourself. Please, all the participants, keep quiet. And this is the introduction to the subject as well as the unit, limits, fits and tolerances. So the course outcome, we have to design the parts, the components which you draw in production drawing or machine drawing. So we have the different so we have disturbing, I think, and your particular result also will not be good in 3-1. So I'll remove the participant if I think is disturbing, and it will not be for the whole semester also. Somebody are disturbing just for the sake of fun. So will be reported to the principal and HOD and will be removed from the class. Sairam has joined. Sairam. So we have the this type of nuisance. Somebody are just creating nuisance. So as far as the course outcome is concerned, the first one, we have to design the components that are drawing in production drawing, and we have to establish the tolerances, individual tolerance. So we have to establish the tolerances. Tolerances is on the individual component, and allowance is on the mating components. That is the male and female component. So we'll just try to discuss in the unit or the chapter. So as far as the standard mechanical components, you have many components, shafts, bearings, the different types of shafts, linear, the tapered shafts or the spline shafts, or the components, whatever you try to say, bush and shaft or different combinations. You try to, if you want to mount a pulley on the shaft, then we have different things. So we have the, so we'll try to remove. So I'm warning you, my dear participants. We'll try to list all this 37 participants, and when you come to the college, you're asked to explain why you're not allowing me to take the class. You're purposely putting some songs which are not good for the teaching community, and you'll be severely punished. So I don't know. My phone is not working properly, sir. It is your headache. You have to, mic is automatically on means you have to keep your mute yourself. I'll try to give attendance. You try to get out from the class. So some people are purposely doing. I know you. I see in the mentality in the lab or in the some of the classes, you are still not accustomed to the offline class from the online mode when we met in October or November I think. So please, so mic is automatically on means you please go away. I will give you attendance. Okay, please, 327. Please stay away from the class. Please stay away from the class. Please stay away from the class. 327. I'll give you attendance. Because of you, all are being suffered. I'll report the matter to the HOD. So second one is the linear angular measurements. Linear means we have the scale, the steel rule. Steel rule we say the particular micrometer, vernier caliper, different things we have. So if your phone is not working, you please leave, because if the mic is automatically on, I will be disturbed, and because of you, all will be disturbed. All the 40 participants who have joined, I'll give you attendance. 310. I don't know your name, but you have to listen to the faculty. So The next one is optical methods. We have the tool makers microscope, optical projector, different things are there, different devices are there in the metrology lab. So optical means we have the tool makers microscope and the profile projector. Okay, so all these are the different. We have the optical bevel protractor also. Apart from the universal bevel protractor, angular measurements, we have the indirect and direct measuring instruments. We have so sine bar or the sine center or all this are the things, and universal bevel protractor is for the direct one. So we have the different surface finish methods, techniques. We have the different Taylor's and Taylor Hobson Talisurf or Tomlinson surface meter. Different terminology we'll try to see. Gears we have spur gear metrology, screw threads, different types of screw threads. Screw threads simply we can say minor diameter, major diameter, pitch, and thread angle. We have one of the experiments in the lab, and alignment tests we'll try to discuss later. So all these are definite parts, and we'll try to see all of them. I don't know why somebody is starting still. So these are the 5 course outcomes. These are the 5 course outcomes we have. So we have the this will cover all the syllabus as far as the metrology part is concerned, and metrology is the science of measurement. So we'll just try to stop this sharing and directly go to the unit 1. So this whatever 1 to we'll just try to specify afterwards what course outcomes or this it will be defining the levels and the Bloom taxonomy levels that you don't know. Only in the class we can say, but we'll directly go to the this one chapter and we'll go for the new screen share. Okay. So as far as the new screen share is concerned, it is the limits, fits, and tolerances. So we have the course code is different, but we'll just try to follow this one. So this is the new first unit, that is the limits, fits, and tolerances. So we have the references also. So you can follow any textbook, but I.C. Gupta is a very good book. So we have different textbooks. We have you can follow engineering metrology by R.K. Jain, I.C. Gupta, and we have the other books also. You can follow engineering metrology by some of the well-known authors, and we have reference books like Raghavendra and Krishnamurti. We can have the Oxford University Press, and we have the different. We can follow the NPTEL links for the reference. We can have this link if you just try to click. We have the different mechanical measurements or the metrology part. So first one, in some of the unit, in unit 2, gauging is there. So I am just clubbing that with unit 1. After finishing the different terminologies or different topics with respect to limits, fits, and tolerances, we'll try to go for gauging, because the gauging is designed as per the Taylor's principle of gauge design. That also we'll try to see. So what is the learning objectives in this particular chapter? So after completion of this particular chapter, the students will be equipped with the knowledge of limits. So what is the limit, upper limit and lower limit, fits, types of fits, clearance, transition, and interference? We'll just try to see. Already I told you tolerance. Tolerance is on the individual component, but whenever you try to speak of allowance, allowance is on the mating components. Mating, positive allowance, negative allowance. Depending upon that, we'll try to classify the fits. Positive allowance, we have the clearance fit. Negative allowance, we have the interference fit, and both positive and negative allowance, we have the transition fit. Gauging we'll try to see as the second part of the chapter. So what are the outcomes? So what are the outcomes? So actually, the outcomes are, if you try to just appreciate this significance the different types of limits, fits, and tolerances. Because in the design part, whenever you are designing the particular components, and whenever the manufacturer or the production people will try to load on the machines those particular components, we have to have the control, the process control on the manufacturing aspect or the production aspect. So that's why you have to have, because any particular component, suppose 25 is there as far as shaft is concerned, is the basic size. It may be for a bush or a shaft, but you cannot manufacture a component, the bush or a shaft, exactly to the basic size. That's why you are providing some tolerance on the component, that is a shaft or a bush. So we have to have 25 plus or minus O2. That means plus O2, 0.02 mm plus 0.02 mm, 25 plus 0.02 m, 02 mm. 25.02 is the upper limit. So plus or minus side if you go, it is 24.98. 24.98 is the low limit. So whenever a manufacturer or production people tries to manufacture the shaft, you will be seeing that you'll be maintaining that 25 mm. But if any process deviation or tool, the tool will get burnt, or the production people, in order to enhance the production, they try to increase the speed or something, disturb the machining parameters. So suppose you are disturbing the machining parameters, means what? The surface finish will be affected. That's we'll try to discuss later. But we'll try to maintain the shaft dimension between 25.02 to 24.98. So that is how we have to just. But how? What is the foolproof? You cannot measure each and every component, because the individually, just in an hour, the production people will try to go for a few sampling, but it is not his headache. That's why his headache is only to produce. But the quality control people or the quality assurance people will be there to have a control on the manufacturing process. So they're using different gauges, the shop floor gauges we have on the shop floor. But if you try to design the shop floor gauges as per the design, then there is a problem of rejection. Either the component may become oversized. Suppose for a means, what is that? 25 point, suppose more than the basic size. So if external dimension oversize means you can rework. But if it is undersize, you have to reject. The opposite is for the bush. Bush undersize means there is still some material. Bush is like a hole. So we can rework when it is undersize as far as the internal dimension is concerned. But for the external dimension, only for oversize we can rework. But you should not think of concept of rework in the beginning itself. Your task is to control the manufacturing process within the specified limits, within the prescribed limits. So as per the design. So that's why the role of gauges, the role of instruments, and the role of comparators will come. Comparators chapter is also there in this particular syllabus. The different comparators: mechanical, optical, electrical, and electronics. So we'll just try to speak of when we try to come to that particular unit chapter. It is in the surface, the third course outcome, that is the comparators. So here we have the for this particular limits, widths, and tolerances are very important in the design and manufacturing fields, because if you want to efficiently run the production, and we have to have the effective performance of the components after the manufacture. So after the manufactured, if you just try to measure them and say all are rejected. It's not like that. You have to have a control during the production process only. That's why this particular limits, fits, and tolerances are very important in the design and manufacturing fields. And the functional aspects also have to be tested. The functional, not only the dimensional aspects, just like what I told, 25 plus or minus O2, but you have another part, that is the geometric features, that is the circularity, roundness, the squareness or perpendicularity, parallelism, the positional tolerance. Suppose you are drilling a hole. If you are not drilling a hole at the exact position, what is the use of that? So that is the positional tolerance. So we have all that. We just try to discuss in the ensuing chapter, because this is an introduction class. I am telling you what are the particular important keywords in this chapter. So after the second one, understand the importance of manufacturing components to specified sizes. That's very important, because as a student you are reading theoretically, but how this quality control and quality assurance is very important. I myself have seen in, when I worked for 5 years in the automobile industry. So we have designed not only the gauges for the shop floor to avoid rejections. We have designed some of the gauges for measuring the riser and runner, the shape or the padding length, padding width, or padding depth. So you might have seen in the manufacturing process one or production technology, those particular aspects as far as the dies are concerned. So tools and dies, gauges are very important in the manufacturing industry, because without that, the tool room manufacturing person who is preparing a single point cutting tool or a multi-point cutting tool, he cannot say, if he's though he is sticking to the drawing and trying to measure, but there is a particular measurement technique as far as the tool is concerned in the profile projector. So what is the main theme of this metallurgy subject, sir? So main theme is you have to go for the science of measurement, because any component, if is measured and directly sent to the particular suppose a automobile industry or an aerospace industry or any other industry without checking, because this is a quality check, science of measurement. So you are having a quality check on the components and trying to segregate the components which are okay, which are undersized, which are oversized, and trying to send the quality components to the packing section or to the automobile industry or the aerospace industry, so that functionally they are viable. Functionally, they have to mate properly. Mating, that is the combination of the male and female components. So according to the desired type of fit. Suppose a manufacturer says, the particular customer says, I want this type of fit only, I want only transition fit. You have to see that you try to design your components according to this, and you have to have a quality check during the production process by using the different limit gauges. So we have the snap and ring gauges for the shafts, ring and snap gauges for the shaft, and for the holes, checking of the holes or bushes, the internal dimensions, we have the plug gauges. That's why I want to answer to the chat. So you can put any particular questions, because I don't say I'm an expert, but at least I have practical experience and developed the inspection procedures, the standard procedures for the inspection of the tools, for the dies, and the rejection levels have been reduced drastically as far as the different casting defects are concerned in the foundry. So in the industry, mainly I was first a process line inspector for the 6 months. After that, I've changed over to the tool room, tool and die inspection. Then after that, the incoming material, whatever material is coming into the factory, important components, important tools, important gauges, which are used in the machine shop, the pin shop. Pin shop means gauge and pin, but you'll be learning in the automobile section also. So that is the tool room foundry. So we used to check, and afterwards we are related to the machine tools. That is the lathe machine or but lathe machine may be there in the industry, in the tool room or the milling machine or the shaper. But for the manufacturing of a piston, we used to have the different special purpose machines. They were first imported from Taiwan. The company was just collaborated with Taiwan. But after that, after knowing the design, we used to procure from Hindustan Machine Tools, a different Coimbatore or different machine tool manufacturers. And after that, the company has started its own machine tool building. So for that, I was the quality control or the quality assurance check. So that we'll try to concentrate more upon in the last unit, alignment tests or the acceptance test on machine tools. So it is the most importance in the industry. So this the first unit we have the system of limits, fits, tolerance, and gauging. So we have to define the different types of assembly also. So interchangeable assembly, selective assembly. Previously, people used to use the crude methods of the trial and error assembly, but it's now outdated. Interchangeability means suppose 1,000 shafts and 1,000 holes or 1,000 bushes you try to manufacture with skilled people or semi-skilled people. The first shaft should be interchangeable, uh, should be mating with the 100 bush, or the 100 shaft would be mating with the first bush, or interchangeability. So selective assembly means it is selective only. You have to have some particular grades as per the design or for the design, or as per the drawing. We have different grades. Suppose for a piston, skirt grades will be there. Piston skirt is there now. We have different grades. That is black or white, depending upon the model of the piston, model of the automobile. Just like Bajaj Classic, Bajaj Chatak, previously LML, Vespa, TVS. So selective grade means, suppose I give an example of piston as a shaft. I take an example of piston as a shaft. Where you try to assemble the piston, you have to assemble the piston in the cylinder. So cylinder block, what I mean to say. So cylinder block will have the internal dimension of the cylinder block has to be matching with the external dimension of the piston. That is the selective assembly. So that is very important as far as the different types of assemblies are concerned. Important means I'm just speaking in terms of the academics as well as the functional aspects as far as the industry is concerned. So class and grade of tolerance. We'll just try to discuss this because we have the international grade from IT0, IT01 and IT01 to IT16. 18 grades of tolerances are there. And according to this, we have the different topics we'll try to discuss related to this. Types of fits we have. Already I told you transition fit, the clearance fit, transition fit, and interference fit. So this whole basis system, not whole base, it is actually whole basis. Whole basis system and shaft basis system is very important as far as the academics are concerned. The Taylor's principle of gauge design is concerned. We have for a gauge, go should go, no go gauge, no go should go. So go gauge is designed as per the maximum material limit condition or the MMC, maximum metal condition, and no go gauge is designed as per the LML. You use MML and LML because you'll be concerned we use M both for max and minimum. So we have all these types of the limit gauges designed as per the Taylor's principle of gauge design, go gauge and no go gauge. Some say not go gauge, but common terminology we use go gauge and no go gauge. Because already I told you for the shafts, ring and snap gauges, you may be wondering why ring and snap gauges. Snap gauges are used both for cylindrical and both types of works and uncylindrical works. So like that, we have the plug gauges for the bushes or holes. So here, what I meant to say in the introduction part, in the beginning itself, I told you no two components, no identical components you cannot measure in this universe. As far as suppose you are want to manufacture 100 shafts, uh, any two or any one will be, any few will be matching with the identical measurements, but it's not so possible. That's why the concept of the limits, fits, and tolerances, or the concept of the gauging, to have a check on the manufacturing process, has been introduced. The gauges have been introduced from the quality control side. So it is a good check, because it is, production people also will be glad or happy, because they'll be getting the feedback from the quality control inspectors or the QA engineers on the shop floor, who will be checking for a frequency of 1 to 2 hours. 1 to 2 hours. Suppose an 8-hour shift, four times the quality control inspector will go and just have a sample of components checked, because in the industrial engineering concept, we have single sampling plan and double sampling plan. I don't want to discuss here, but at least you have to check for every 2 hours, means at least you have to check 10 to 20 components on that particular machine, and try to note them in the particular notes or the inspection charts, how the particular dimension of the component is deviating, or from the drawing, or whether it is within the prescribed limits of size, within that particular drawing limits. So how carefully it is maintained, you have to see. And a certain amount of variation will exist, but that variation should not be much. So if it is variation is much, you try to give a memo. Memo means you just try to give a feedback to the production engineer or the production supervisor there. No, don't directly talk with the operator, or just try to say, you just try to stop, there's some variation. I'm just trying to inform your production engineer there is a large amount of variation, and you will try to the machine setter for a different group of machines, or a machine setter for that particular machine, if he's an expert, he will be just checking if there is any variation, if there is any tool blunt, if there is any setting variation, and you will try to set it. So after setting also, if the production supervisor tries to ask you, your particular role is to check, your responsibility is to check after setting of that particular machine, and the production process should not be hampered. You have to cooperate with the production people, the quality assurance people, because you have a good knowledge on the science of measurement. Metrology, don't say metallurgy, my dear friends. Metallurgy is very different. Metallurgy is material science, and metallurgy, that the particular scanning electron microscope analysis you try to do after fabricating different composite materials or nanomaterials, that is different. METALLURGY, metallurgy is different. This is metrology. METROLOGY. You try to be specific of the spellings. Why I'm telling people in the labs, or in the even in the external papers, and people try to confuse from metrology to meteorology also. Meteorology is different. It is a weather report. So this is metrology. METROLOGY. Metallurgy is different. So as far as the mechanical subjects are concerned, we have both material science and metallurgy. That is the iron carbide diagram, iron carbide equilibrium diagram you have seen, but this is different. This is the science of measurement. So, what are the variations that arise? Already I told you, improperly adjusted machines. The machine setting is not proper, the variations will occur in the dimensions of the component. The dimensions will vary. If the dimensions will vary, naturally the geometric features will vary. That symbols also I'll try to, that whatever the things are there, in a table we have 14 types of geometric features. We'll try to see operator error also. Operator, if is relaxing, also if the tool is unwanted toolware, you have to observe, the operator has to observe the tools also. Toolware we have discussed in the metal cutting and machine tools also. And mind you, I already told you invert material quality control I've seen, the defective raw materials. You have to just reject them in the beginning itself. If we are using defective raw materials and or the material is good, if you are not concerned with the heat treatment process in the carburizing furnace or the particular furnaces in the foundry, and you are machining in the soft condition, there also you'll find problem with the machining. So up to a certain level, you have to go for heat treatment and check the hardness on the Rockwell or Brenell or the micro hardness, because hardness tester, so that your machining is smooth and your particular surface finish is met. So all these are interconnected. All these are interconnected, my dear friends. Defective raw materials, the materials which are not the materials which are not heat treated properly, you have to go for the material testing lab or the research lab in the lab department for testing, or use the strength of materials lab or mechanics of solids lab for the tensile test or the compression test or the impact test. I judge. All that are very important, my dear friends. And the chemistry or the BSc chemistry or the material science and metallurgy BTech people will be in charge of foundry quality control, because after a casting has been made, they have to cut a cross section and see whether, suppose we have a piston, we have you want to have a 21% or 23%, because piston is a combination of silicon aluminum alloy. If you are getting that particular percentage, how you can check? By proper combination, by proper mixing of the silicon and aluminum. So along with that, you may be mixing some copper, magnesium, or some of the small metals or in traces. But the final thing you have to check. So that's also a very important job as far as the industry is concerned. The metallurgy and material science, if you have a passion for that, because this is an age of the composite materials and nanotechnology. Not only that, I'm a mechanical engineer. I don't want to have any knowledge on materials. That's not correct. So you have to have a knowledge on materials, on the material science and metallurgy also, so that you can write papers. You have to start writing papers, my dear friends. All are enjoying, all are idle. At least that person was somewhat 327. He told his microphone is. I might have thought that you are disturbing just purposely, but that particular sincerity should be there from a student. You have to develop from now onwards with minor projects or simple projects, then develop yourself to making your BTech project fruitful, so that you can write a paper from your BTech projects, MTech projects. All that you have to see. So all this, the assignable courses. So you can see your this assignable courses are the courses which you have in your mind. You can control them. They can be identified easily. You can control easily. So that is the variations. So introduction part, 12 minutes. I'll try to just finish the introduction, and then we'll try the actual part. Will start tomorrow in the whatever period we have. So it is in the already I told you. This in this universe we cannot produce a part exactly to the basic size or the exact size, that is 25 mm or 20 mm of a shaft or a bush. So these are not. That's why we need tolerance. Why tolerance is needed in a component, that you can say in the Viva versi, because Viva nowadays I don't know, because depending upon the time constraint or the laxity of the internal examiner or external examiner, I should not speak of the online class, but you just try to improve your fundamental knowledge so that you can face not only Viva, any interview. When I gone for this interview in the industry, they thought that I was no, my mentality was psychologically I was only good for the quality control or command levels. That manager levels, maybe you can improve afterwards, not only by learning MBA, but after having a few experience in the industry, you can learn. Okay. So this permissible level of tolerance also, already I told you, if we are just writing a C program without any logic, then that program is waste. Like that, we are designing we are manufacturing a component according to the design, and the particular components are functionally not viable. Functional, if we are not if we are not conforming to the functional requirement, then it's a wastage of the material and the time, the manufacturing time, and the inspection time. So you have to see that functionally it should be viable. So you have to manufacture the components according to the desired type of fit as requested by the customer. We'll try to just speak of different keywords in the gear terminology or the screw thread terminology, or in this particular chapter. Okay, so different keywords or new words, you just try to uh, learn from the different units or different chapters in this subject. So no component here can be manufactured precisely. Already I told you, it can be only be made or manufactured to lie between two limits. So what are the limits I told you? Upper limit is, for example, 25.02, 25 plus or minus 0.2 mm. So what is the lower limit? It is the 25 minus 0.02, 24.98. So these are the two limits of size. So you try to manufacture a component between 25.02 and 24.98. So that is very important. So here the designer, the particular people who are in the design department, has to suggest this tolerance limits, because to ensure satisfactory operation. Because satisfactory operation means after the components are passed from the industry, the quality control people, to the particular industry, automobile or the aerospace industry or whatever industry, the components are used. It may be bearings also, my dear friends. Standard mechanical components, bearings also will come. So you just try to check up with that. So this particular difference between the upper and lower limits, that is 25.02 minus 24.98, is the permissible tolerance. Permissive tolerance or permissible tolerance. So that is the word we have to use. So next, already I given an example of 25 point plus or minus 02. This also can be taken. The upper limit for this particular example is 40.02 and lower limit is 49.98. So all that you have to observe. So what is the permissible tolerance for this one? It is 40.02 minus 39.88. So permissible tolerance in NPTEL courses also is asking the tolerance on the individual component, means the permissible tolerance is asking, and you have to say 0.04. Some people will try to say only 0.02 without doing any homework or without putting on paper, the pen, anything. So it is plus O2 plus O2. You can check up with any common example you give, and you can arrive at the permissive tolerance or the permissible tolerance. This is a small example. So what are the tolerances? Why we have to provide tolerances? Because we have to provide tolerances because anytime the customer is not only worried, he is demanding accuracy, but accuracy is not enough, my dear friends. Nowadays we have come for precision manufacturing. We have, because precision tools, we have to have the intelligent manufacturing using the machine learning, using the artificial intelligence. All these are the factories of the future, flexible manufacturing system, computer aided inspection and quality control. Still if people are 25 years back or 20 years back, it's not correct. So that's why you try to gain knowledge from the concerned faculty. It may be manufacturing or design or thermal. You have to extract the knowledge or information. So what is the process? What is now going on in the multinational companies? What are the methods they are adopting? What are the Japanese methods that are adopting? What are the Japanese methods are opting? To have 0% rejection. 0% rejection. So the parts have to be produced with less dimensional variation. So we have to have, it is essential that the manufacturer, so the production people should have an in-depth knowledge. They have to have a knowledge of this particular limits, fits, and tolerances, because not only they have to manufacture the parts within the prescribed limits of size, but they have to manufacture the parts economically also. They have to stick on to the quality. They have to stick on to the reliability. Just like statistical quality control subject, statistical concepts, the control charts, X bar chart, Y bar chart, or the P chart, we have the reliability and quality control as a subject for different mechanical engineers and different universities. Instrumentation, instrumentation branch used to study this subject, reliability and quality control. Or so SQC, statistical quality control. So we have the Six Sigma concepts you try to discuss in the industrial engineering subject. So in order to have the increased compatibility, compatibility is matching between the mating components, you have to follow the strict rules of the tolerances on the individual component. Tolerances means on the individual component, and allowance means on the mating components. So all these are very important, and the algebraic difference between the upper and lower acceptable dimensions is tolerance. So it's an absolute value. So the basic purpose of providing tolerances means you have to permit the dimensional variations from 40.02 to 39.98 as given in the example. So all this you have to follow. So you have to see the performance or the functional requirements or the functional aspects also. Just because I already just given an example, just like writing a C program structure and the logic is missing in that, it's of no use. So tomorrow we'll be just joining again with the tolerances. We'll be continuing with this particular chapter or with this particular PDF or the PPT. And mind you, in the online classes, you have to maintain strict discipline. So that don't worry if you just purposely do, we cannot say. But if the person comes out and says my mic is problem or not, that you have to clarify yourself on your side. You have to just check on your side before joining the class. So don't do the repeat like that. 327 tomorrow you join the class. There's no excuse only for today, because I am totally disturbed in the first 5 minutes. So I've given you the excuse. So tomorrow we'll join and we'll leave. Okay. Thank you for patient listening, and try to come up with the charts. Any questions, or in the groups of third year A section and third year B section, any doubts you have, or in the ensuing classes. Thank you for patient listening.